I'm starting today branches of geography. So today I thought to start some geography portion also. So branches of geography. So I'll discuss here some important points. All right. So first is astronomical geography. Astronomical. Second is geomorphology. Geomorphology. Then climatology. Climatology. Then soil geography. Soil geography. Then oceanography. Oceanography. So one is astronomology, second is astronomical geography, second is geomorphology, third is climatology, fourth is soil geography, fifth is ocean geography. Alright, sixth one is biogeography. Biogeography. Seventh one will be this was the physical geography we will discuss. Okay. Second is human geography. In human we are going to discuss some points. One is population. Okay, population. Second is political. Third is anthropogeography. Then social geography. Then cultural geography. Then economical geography. All right. So in economical geography there are lots of things we will discuss. One is agriculture, then trade, then transport, then industry. Agriculture, trade, transport and industry, these are some important points we will discuss. For that, historical geography and settlement geography for rural and urban, so these are in our course. Then for regional geography, we are going to discuss here macro, micro and meso, three regions. Okay, so everything will be in a small points. You will enjoy definitely, because this lecture is going to become a very enjoyable and very fantastic, even I can say. You will get every area. Then first of all we are going to start with origin of earth. Origin of earth is geocentric theory. First of all, geocentric theory, centric theory. Second was is heliocentric theory. Okay, so two theories are there. First is geocentric theory. This theory is, its final form was given by Ptolemy and Alexandria and Greece. So this was in a Greece, geocentric theory, and it was Ptolemy who given this theory. Ptolemy and Alexandria. The earth is at the center of the universe, and sun, the stars and all others heavenly bodies revolves around the earth. So geocentric theory. Okay, this theory was propounded by Nicholas Copernicus of Poland in his book The Revolutionibus Orbium Coelestium. Second is heliocentric. Sun is at the center of the universe. Heliocentric is what saying? Sun is at the center, okay, of the universe. Earth and other planets revolve around the sun. So Galileo and Galilei given this theory, and Sir Isaac Newton supported this theory. So Isaac Newton also supported the heliocentric theory and geocentric theory, against the geocentric theory. Okay, now next one is Buffon's hypothesis. Buffon's hypothesis is proposed by Comte de Buffon in the French. It was a French naturalist, Comte de Buffon. Earth originated as the result of collision between sun and comet. Sun and comet. There was a collision. Then Earth comes. Okay. Next is gaseous mass theory. Gaseous mass theory. Gaseous mass theory is proposed by Immanuel Kant. Kant given this theory. Okay. Immanuel Kant given this theory, and Earth and other planet originated from the rotating nebular mass. So he given the nebular mass, rotating nebular mass. So this theory is based on Newton law of gravitational. So Newton law of gravitation. This was based on. Okay, next is nebular hypothesis. Nebular hypothesis. So it is proposed by Laplace. De Mosqueus in his book Exposition du Système du Monde. Intensity, hot and rotating, nebular gaseous mass cooled rotation, and subsequently its centrifugal force increased further due to decrease in volume of the masses. So it is based on rotation of the Earth, and centrifugal force increased in particular, and due to the decrease in volume of the masses. So due to centrifugal force, a ring of masses separated out nebula and transformed into the planetary bodies. That is given the nebular hypothesis. Okay. Next is planetesimal hypothesis. Planetesimal hypothesis. So this planetesimal hypothesis was proposed by T.C. Chamberlain. Okay. And F.R. Moulton. Okay, a star passed by the sun and drew out some material which later condensed into planetary body. Next is tidal hypothesis. Tidal hypothesis is proposed by Jean James Jeffrey. Tides of gaseous masses from the sun created as a result of higher gravitational force from an approaching stars. So there is the sun and tides, gaseous masses from the sun created as a result of higher gravitational force. Sun created because of the higher gravitational force from an approaching star. Next is tidal hypothesis. Next is electromagnetic hypothesis. Electromagnetic hypothesis is about the proposed by Hannes Alfvén. Electromagnetic field around the sun attracted the dust and gaseous masses. The dust and gaseous masses revolved around the sun and condensed into planet. At a later stage, the planet grew their own magnetic field. And next is binary hypothesis. Okay, binary hypothesis proposed by the Rosell and Littlin. Next is supernova is about proposed by the Hoyle and Littleton. Okay. Revised nebular hypothesis proposed by Schmidt, Russia, and Carl Weierstrass, Germany. The sun was surrounded by solar nebula containing hydrogen, helium, and dust. The friction of collision of particles led to formation of disc-shaped cloud. The planets were formed through the process of accretion from the cloud. So this is revised nebular hypothesis. And last one is Big Bang. It is very important. Big Bang. So Big Bang was expanding universe hypothesis. It is known as expanding universe. Edwin Hubble given this hypothesis, Big Bang. Hubble. So proposed evidence of universe is expanding, and Big Bang took place 13.7 billion year ago. 0.7 billion year ago. Okay, an explosion of small mass at the extremely high density and temperature led to origin of universe. The expansion still continue, and as it expands, some energy is converted into matter. There was a rapid expansion within the fraction of a second of Big Bang, and thereafter the expansion within 300,000 years from Big Bang temperature dropped to 4500 km and gave rise to atomic matter. Expansion of the universe supported but not as expansion of galaxies. So this was around that. Now we are going to discuss about the layers of the earth. Now we are going to discuss about the earth. So this is the earth. Okay, and here is some layers. These are some layers of earth. You can see here one is exosphere, then thermosphere, then you see mesosphere, then you will see stratosphere, and then you will see troposphere. So in the earth there is troposphere, then stratosphere, then mesosphere, then thermosphere, and then exosphere. This is the structure of the earth. So this is the environment, structure of the environment. Okay, but if we are talking about the earth, there should be an inner core. Here is the inner core. Okay, then there is outer core. It is the outer core. Then is mantle. It is the mantle. Then is upper mantle. This is the upper mantle. Okay, so this was the inner core, then outer core, then mantle, then there is mantle, then upper mantle, and this is crust. Upper mantle, and this is crust. Okay, so all about this. So we are going to discuss about, first of all, shape of the earth. So shape of the earth is generally spheroid. Shape of the earth is spheroid, slightly flattened at the poles and bulging of the equator. So it is slightly flattened to the poles and bulging in the equator. It is equator, 0 degree. Okay, so crust. First of all, crust. So crust is outermost layer of the earth, continental crust and oceanic crust. So composition made up of solid rocks, made up of higher elements like silicon, aluminum, oxygen, known as Cl. Okay, so crust is made up of Cl and falcites, silicon, aluminum, and oxygen. Element of percentage, if we are talking about the element of percentage of the crust, then oxygen is 47%, silicon is 28%, aluminum is 8%, iron is 5%, calcium is 3.5%. Okay, and compounds by the percentage: silica, first of all silica, then alumina, then lime. This is the composition of the earth. Okay, first of all oxygen is in the higher percentage in the crust, then silicon, then aluminum, then iron, then calcium, then silicon, alumina, and lime. 3 are there. Okay, now we are going to discuss about mantle. Okay, mantle is layer below the crust. So composition is silicon plus oxygen plus magnesium. Silicon, oxygen, and magnesium. Silicon, oxygen, and magnesium. These are the composition on the mantle. So if we are talking on the mantle, there will be silicon more than oxygen, then will be the magnesium. It is known as SEMA also, or mafic. Okay, and the density of the mantle increase gradually with the depth. If we are going in the depth in the earth, its density will increase. Okay, and layers, if we are talking about the layers in the mantle, so there is upper layer. Upper layer is solid based. Then upper asthenosphere. Upper asthenosphere is layer is fluidic due to high pressure and temperature. High pressure plus temperature. Okay, and leads to movement of continental plates. Now lower asthenosphere, then lower mantle, This is the structure of the earth. Alright, now we are going to discuss about the core. Core are the innermost of the earth. If we are talking about the innermost, it is the core. Okay, so core is core is made up of solid iron and nickel. Okay, and outer core is molten layer. Outer core is the molten. It is the molten, and inner core is solid. It is solid. Okay, and now are the boundaries between layers Earth? So found by the analysis of seismic waves. So how do we found this all? Seismic waves. These boundaries found by the seismic waves. Now discontinuities are there. So discontinuities are very important. First is Conrad discontinuity. Conrad discontinuity. So Conrad discontinuity is between upper crust and lower crust. CC and Conrad, you can see that Conrad discontinuity. Okay, so name the Victor Conrad also. Second is Mohorovicic discontinuity. It is between the crust and asthenosphere. It is between the crust and asthenosphere, named after Andrija Mohorovic, and it is lies depth about 20 miles under the continent and 5 to 6 miles under the ocean. Now third is Zapati. After Moho there is Zapati. It is between upper mantle and lower mantle. It one is third one. Now fourth one is Gutenberg. So Gutenberg is between lower mantle and core. Okay, lower mantle and core. And last one is Lehman is between the outer core and inner core. See, L is for love, so love is in inner more core. It's outer core and inner core. Okay, it's just mnemonic for learning. Lithosphere. Now important point. Lithosphere is the, what is lithosphere? Lithosphere is for the crust plus upper mantle. So it is oceanic lithosphere and continental lithosphere also. Now important points. Thickness of the continental crust is higher than oceanic crust. So thickness, if we are talking about the thickness of the oceanic continental crust, it is higher than the oceanic crust. Okay, mantle is the largest layer by mass of volume, and mantle is the largest. Booze like mantle, then core, then crust. So mantle is the largest by the volume, followed by crust. Sorry, it was wrong. Followed by crust, then core. Core is the smallest one. Okay, so this is the ratio about that mantle, crust and core. So core is the smallest one. Oceanic crust is denser than continental crust. If we are talking about density, then oceanic density will be more than the continental density. So if we are talking about the density, then oceanic density will be more than the crust density of continental crust density. So this was all about the earth and its evolution of the earth. Hope you enjoyed.